we're looking at an expression that contains an exponent. It is read 4 to the third power. It could also be read 4 cubed. A number that is written with an exponent is in exponential form. The large number, in this case the 4, is the base, and the small number at the upper right, in this case the 3, is the exponent. The entire expression, 4 to the third power, is called a power. We look at it again, and many of you already know that 4 to the third power means 4 times 4 times 4, and if we multiply it out, we get 64. Here's 2 to the fifth power, which means 2 times itself 5 times. We multiply it out. 2 times 2 is 4. 4 times the third 2 is 8. 8 times the fourth 2 is 16. And 16 times the fifth 2 is 32. Here's 1 to the fourth power. 1 times 1 times 1 times 1, which of course is still 1. Here's 42 to the first power, which is just 42. Any number to the first power is itself. Here's 10 to the first power. Of course, that's 10. 10 to the second power, of course, is 100. 10 to the third power. 10 times 10 times 10, 1,000. Here's 10 to the fourth power. 10 times 10 times 10 times 10, or 10,000. You may have noticed by now that the exponent 4 is the same as the number of zeros that is in our final product, in this case 10,000. And that brings us to a simple rule. To multiply an integer by a power of 10, just add a number of zeros the same as the exponent. So if we have 42 times 10 to the fourth, we add 4 zeros, and we get 420,000. 6 times 10 to the second, we add 2 zeros, and we get 600. Here's 3.14. If we use that rule to multiply this number by 10 to the second, we just add 2 zeros. But you can see that adding 2 zeros to 3.14 does not change its value. 3.1400 is equal to 3.14. But if you recall the rule says when multiplying integers by powers of 10, and 3.14 is not an integer. But we have a rule for numbers like 3.14, and here it is. To multiply a number containing a decimal point by a power of 10, just move the decimal point to the right the same number of places as the exponent. Then fill in zeros as necessary. And here's an example. 6.234 times 10 to the second. We move the decimal point 2 to the right as shown. We show a little work. Then we realize that our new decimal position is between the 3 and the 4. And then we rewrite our answer down at the bottom so it's clear. 623.4. Here's 3.1 times 10 to the third. And we start by writing 3.1. We need to show a little work, so we wrote it below. And then we move our decimal point 3 places, but we have 2 blank places, and that's the places where it says fill in zeros as necessary. So we fill in those 2 zeros to be placeholders, and then we write our final answer. 3,100 is the answer to 3.1 times 10 to the third. The second power and the third power have special names, squared and cubed, and here are 4 examples. 4 is the same as 2 squared. 8 is equal to 2 cubed. 9 is equal to 3 squared, and 27 is equal to 3 cubed. And here's a list of 12 numbers known as perfect squares. The list actually goes on infinitely, but this list is the perfect squares for the first 12 counting numbers. And what that means is that the 1, the first number in the list, is the same as 1 squared. 4 is equal to 2 squared. 9 is equal to 3 squared, and so on. And here's another list of 12 numbers that also goes on infinitely if we like. But this is the list of the perfect cubes for the first 12 counting numbers, where the first number in the list, 1, is 1 cubed, 8 is 2 cubed, 27 is 3 cubed, and so on. And while we're looking at these 2 lists, here's a pair of numbers that appear on both lists. 1 is both 1 squared and 1 cubed, and 64 is 8 squared and 4 cubed. Those words squared and cubed are used for a reason, which I'll try to demonstrate here. In the top, we see a square, 4 units on each side. So 4 times 4 is 16, and you can count 16 smaller squares in the interior of the overall square. So we say that 4 squared, or 4 to the second power, is 16. And at the bottom, we have a representation of a three-dimensional object known as a cube, which is 4 units on the length, width, and height. So if we slice that cube up, we can get a layer of 16 at the top, which is 4 squared, 16, but there's 4 layers, so 16 times 4 is 64. So we say that 4 cubed is 64. And our other example is a square for 1 squared and a cube, a 1 by 1 by 1 cube, representing 1 cubed. In this lesson, we looked at exponential form, exponents, bases, powers, powers of 10, cubes, and squares.